Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question that was submitted by a student. This is an interesting one, having to fit a sine or cosine curve to this given the information. It's kind of unusual, so I thought I'd give it a try. I'm going to start by just trying to sketch some sort of graph. Okay. So this is midnight here, which is 0 hours. Think of a clock. And then there's 24 hours, obviously, in a day. And we're told that the temperature is 60 degrees at midnight, so that would be a 12 here. It's at 60. And the high is at 74. So we know it has to get back to 60 again here. And this is 74. We know it has to start at 60. And 46 is the minimum, but we don't know where that minimum lies. But it must be in here somewhere. Okay, we need to fit a curve to this. Well, how are we going to do that? Well, we certainly can find the range, and the curve is not starting at a midline of that range. Let's see, the range would be 74 minus 46, which would be 28. So the range is 28, so 28 over 2 is 14. So 46 plus 14 is 60. So that is the midline. So that is the midline because it's halfway between the high and the low. So it has an amplitude of 14 because this distance from here to here is 14 units. And from here to here, 14 units. Actually, the units are degrees. So it's 14 here to here, 14 here to here. So that's a midline. So it's starting at a midline and it's going down, and then it has to cross the midline at some point and get to the maximum, and then get back down to the midline. So what does that look like to you? That looks to me like a sine curve. Just going to move this point a little bit, move these points around a little bit so we get something that looks more friendly. So it's going to just move this one around a little bit. So here we are. So it's going to go down to the minimum, and then we don't know when it crosses the midline again, but it would be a 12. It would have to, because it's got to go back up here and then down here. So that's our curve. And so now we can fill in all the other things. So our period is going to be from 0 to 24. So we have amplitude and period. We don't have a horizontal shift because we're starting at the midline. And there's the vertical shift is up 60. And it's going to be a negative sine. So you have to have memorized what these curves look like. So the sine curve starts at the minimum and goes up. So that's y equals sine x. But the negative sine curve starts at the minimum. Sorry. Negative sine curve, that's y there. So y, oh, I got the wrong tool. Y equals negative sine x. That's going to start at the midline and go down. So that's why we can see that we have a negative sine curve. So now we're ready to write the equation. For this, we have to memorize the standard form of the equation, which is a sine b x minus h plus k. And we have to find b here. The period is 24. The period for the sine curve is going to be 2 pi over b. 2 pi over b. So that means that b is equal to 2 over 24, so it'll be pi over 12. You see that? I just solved for b here. So it'll be 24b equals 2 pi, and then divided by 24. Okay, so now we're just about done. So we know it's a negative sine curve. We know that a is 14. And we know that b is pi over 12. H is 0, so I don't have to put that in. And up 60. And that should work. You can put that into your calculator and check it and see if you get a curve with all the points that were given to us, and I think you will. And that's all there is to it. This is an interesting one because, you know, they really made it kind of mysterious. They don't usually present problems this way by giving you 3 data points. But because it starts at 60 and has to come back to 60, that gives us a natural period here of 24. And the symmetry here of the highs and the lows about the midpoint here give us the amplitude and the vertical shift. And there's no horizontal shift, so it's not that hard. But I can understand why this would confuse somebody who isn't used to seeing them. I really had to think about it as I was doing this. I couldn't just roll right through it. So this was a nice, interesting one. That's it for this problem. I'll see you again next time. Bye-bye.